Okay, boys and girls.
We're going to continue our lesson. So last week we stopped at lesson number 4.
Right? Okay, before we continue to discuss the questions, so we roughly recall a bit, okay, about the motion graph. So in our year 10, we will learn two motion graph. One is called distance time graph. Here, distance time graph. Another one that today we will learn is called speed time graph. So at here, it will be the speed time graph, okay? So for the distance time graph, from the graph, we must get some information. We're able to interpret some information from the graph. Okay, so at here, when we're finding the gradient, we will find that at the end, the unit that we get is meter per second for the distance time graph. Meter per second actually is the unit for speed. So when we calculate the gradient from this graph, we are calculating the speed. Okay, so look at the first one. We recall if horizontal, there is no gradient. Okay, gradient is your mathematics. Y2 minus Y1 divided by X2 minus X1. Okay, so if you using these 2 points, you do two calculation. Okay, these 2 points, do calculation for the gradient. You will find that the gradient actually is 0. Horizontal, no gradient. Gradient is 0. So at here, this one, gradient 0, 0 speed. Zero speed means what? It doesn't move, okay? So you see at 20 meter at here, okay? They're standing at 20 meter from a certain point, okay? 20 meter, then they're standing at there, okay? Start the stopwatch, 0 second, 1 second, 2 second, 3 second, 4 second, and 5 second. At the end, after 5 second, it's still standing at 20 meter. So this is, we say the object is at rest, or we say stationary, okay? So look at this. Does the object moving? Yes, because it's increasing the distance. Distance starting from origin, 0 here, it start to move. Then 10 meter, 20 meter, 30 meter, 40 meter, 50 meter. 1 second increase 10 meter. Another 1 second increase another 10 meter. So can you see that it's moving with constant speed? So if we're using gradient to explain, you will find that no matter which triangle you draw, from what point to what point doesn't matter. As long as it's a straight line, the gradient is constant. You will get a constant value, only one value for gradient. Constant gradient means constant speed. So for this graph, object moving with constant speed. Okay. Next, page number 2. Okay. So this one is a curve. If there is a curve, so you will find that the gradient already start to change. It no longer just like just now straight line is a constant gradient. No, okay. So at here, if I draw a triangle, you see I draw a triangle, you will find that my triangle also different. Okay. In order, if we want to be very fast, we no need to draw this triangle. We just draw this color, okay, the highlighter, this color, this line and this line. We compare their gradient, the steepest, okay, which one steeper? If steeper, that means that higher gradient. So if I draw like this line and this line, of course, I found that the second line behind, okay, at 4 to 5 seconds there, the line that I draw is steeper line. That means that higher gradient. Higher gradient, that means higher speed. So at here, this is higher speed, this is slower speed. Slow to fast actually is acceleration. Okay, so this motion graph actually is acceleration, the increasing the speed. Speed is changing because gradient is changing. Okay, so this one is object moving or not? Yes, it's moving from 0 to somewhere, okay, some meter. So it's moving. So if I draw, I don't need to draw a triangle. If draw triangle is like this, draw triangle is like this. If I don't want to draw triangle, I'm just using this line to show the gradient. Okay, so this line at start this section, starting initial section, actually is steeper line. The line is steeper. This one is less steep. So that means that here is fast speed goes to slower speed. So actually is moving, yes, but slow down. Okay, this we say deceleration. So I draw the gradient like this, like this. I know that this is higher gradient. Okay, so for the gradient for distance time graph, we can determine the speed by using the gradient. Okay, so this blue line and yellow line, Which one faster speed? Answer is the blue line, because blue line has a higher gradient. Okay, steeper. The line is steeper, higher gradient. So this one is larger speed. But actually both of them moving with constant speed. Okay, for example, here is maybe like 6 meter per second. This one maybe is like 3 meter per second. They keep on maintaining at 6 meter per second. Then the yellow color is they keep on maintaining at 3 meter per second. So for their own, they keep on moving with same speed. But yellow color with a lower same speed. Okay, the green color at here, blue color. Okay, blue color at here actually is moving with a higher constant speed. Okay, so that day we already settled question 1, 2. Question what? 1, 2. Oh, okay. Like boys and girls, we go to page number 4. Okay, have you guys tried? If no, then we try it together right now. It's okay. Okay. From town A. So we are starting from town A. Then we start our stopwatch. Okay. From town A. Then to the town B. This is town B. So she stopped. Okay. During the journey, distance time graph. This is the distance time graph. Can you determine the total time for the whole journey? From town A to town B, how long they travel? Can you write down the answer? In the chat box, write it down so that I know that you already know the answer, so we can proceed. Okay? Town A to town B. How long the time? Total time for the whole journey. Okay, correct. So at here, your friends give me the answer 1.75 hour. Yes. So you have to go down here and read it. Okay. So you have to read it correctly. Then you only get 1.75 hour. Okay. Sometimes the question they will try to trick you. For this question is fine if they didn't trick you. Some of the question they might be trick you. You have to be careful. This is hour. If here they asking about minute, then you have to convert to minute. Okay, not necessarily they will always give you the same unit, so you have to be careful with unit in physics. Okay, so determine the time for which the car is not moving. How long the time actually the car is not moving, right dear?
Correct.
Okay, how about others? Are you guys with me? Because only one student answer me. How about others?
What is the time? Shuan already answered me, and
The answer is correct. How about others? I worry you guys are not with me, so I have to keep on calling your name. Emily, Victor, Ishes, Megan. Right, boys and girls? Or you just open your Zoom, then you playing at the side holding your handphone, huh, dear? Answering my question, right, boys and girls? B, what is your answer? Nobody here? Only Shuen? Okay, finally Emily is here. No, Emily, no. Try again. Yes, Hui-Tong, correct. Okay, right, dear, here. This one, what is this? And then here, what is the time? This is the part that object not moving. This is the part that object not moving. Okay, is it 1.25? Here, is it 0.75? I don't have calculator. Let me check. Okay, wait. Mm, okay, yes. Like boys and girls, this one is 1.25, half of it. This one is 0.75. So how long the time the car is not moving is 1.25 minus 0.75. So our answer for this should be 0.5 hour. Okay, it's 0.5 hour. Let me have a look, Megan. Yes, correct. Okay, so boys and girls, you have to identify. Here is at rest. This part actually is at rest. The distance does not increase. This is at rest. Okay. Okay, we look at the next question. Determine the distance between town A and town B. Like, boys and girls, town A and town B, how far the distance? Correct, Xuan, correct. Correct, Emily, correct. As I told you guys, be careful with the unit. Of course, this question, they didn't trick you. Kilometer. Here, kilometer is fine. If they give you meter, you have to change. Okay, how about others? Did you able to get the answer? Answer at here, from town A to town B. Town A to town B, how far? This is the answer. How far? 100 kilometer. Okay, like boys and girls, we write 100 kilometer. Calculate the average speed of the car between 0 to 0.75. Okay, here. They want to know about this first section. What is their average speed? So, boys and girls, average speed is total distance divided by total time. Do calculation right now. Total distance divided by total time. No, Hui Tong, try again. First section, Hui Tong. Because they want 0 to 0.75 hour, this part only, the front part. Try again. What is the distance? What is the total time? Xuan? I think you already get answer, is it? Emily? Try. Yes, correct. Xuan, correct. How about others? Megan? 0 to 0.75. So read the question carefully what they want, from what section to what section. Yes, Emily, but I want you make it two significant figure. Make it two significant figure. No, two. This is, your answer is two decimal place. Your answer 66.67 actually is two decimal place. So you have to convert it into two significant figure. That is 67. Yes, correct. 67 is correct. Like there at here. What is their average speed? Average speed, dear. Average speed is actually total distance divided by total time. Okay, total distance at here, if you read it here, half of it, half between, why I cannot draw half? Oh, here, go here. Where somewhere here, okay, 50. Okay, so at here, 50 kilometer divided by the time. Time is 0.75 hour. So our answer should be 67 kilometer per hour. Okay, two significant figure, 1, 2. So two significant figure. Okay, Hui Tong, is it okay? Okay, everybody, is it okay? Give me some response, the reaction symbol. Okay, emoji. Then if okay, then we will proceed to the page number 5. Okay, Megan say yes. Okay, Shu En. Okay, Hui Tong, okay. Like boys and girls, we go to the next page, page number 5.
A family goes on holiday in a car.
To stop the journey being boring for the children, every half an hour they note down the distance they have traveled since they left home. Then they plot the graph. Okay, so this is the graph. Every half hours, then they plot. They mark down Okay, they record it down and they plot the graph. The first half hour and last half hours of their journey are on small route. First half is here, last half is here. Okay, these two region or journey actually is on small routes. The rest actually on the major routes. How many hours will they travel on the major routes? Okay, like boys and girls, can you count? I also count. If you get the answer, then let me know. Correct, Shuan, correct. How about others? Give me response, dear. Faster, do it and then tell me your answer. Emily, try again, Emily. On the major route, only on major route. Okay. We don't correct. How about Megan, Licious? Okay, so at here, major route. Okay, read the question, major route. So at here, if I draw it out, so this one first half cycle, first half hour at here, and then this one is another first half hour. Okay, boys and girls, the first half at here, actually this one is small root. The last one also small. Okay, the rest is major root. Okay, so how many hours were they traveling in the major route? Okay, so at here, their answer should be, you look at this, here is 6 hours. Here is 0.5 hours. So you're using 6 minus 0.5. Actually, this is the time on the major route. So it should be 6 minus 0.5. So you get 5.5 hour. Okay, your answer should be 5.5 hour. Last half hour is on small route. First half hour is on small route. The rest of the time actually they are on major route. So you're using 6 minus 0.5. This is the answer 5.5. Is it okay, Megan? 5.5. Okay, here, how far did they travel? Like boys and girls, how far did they travel in total? Megan, do you get it? How we get the 5.5? Okay, good job. Hui Tong correct for the first answer. Continue with second answer. Yes, correct. Hui Tong correct. Correct, Hui Tong. Hui Tong, you can go through and read the C and then try to think about the answer. How about others for the B? Can you type your answer? I cannot be too fast, cannot be too slow. But how fast actually it depends on how fast you give me a response, okay? If I'm too fast, then at the end you might be just copy my answer, cannot. If I'm too slow, it's because I don't know your response. I don't know whether you follow us or not. So please give me response so that we can know that how fast we can go. Yes, correct, Xuan. How about others, Megan? Megan, first one correct, second one and third one, because the third one is depends on second one. So your second one actually is wrong, Megan. The first one correct. Second one you go through on small road, how far the distance? Emily, correct. How about the last one on major road? No, Megan, no. Try again. Small road. Distance on the small road. Small road got two sections, Megan. Emily, correct. Okay, right, boys and girls. In total, at here we got 300 kilometer. So at here, my answer is 300 meter. On small road actually is the first and last section. So you look at this here. Here is 20. The last one at here, only one box, actually is 10 kilometer. 20 plus 10 kilometer actually is 30 kilometer. Okay, so this one should be 30 kilometer on small road. So major road, how far we travel? 300 minus 30, so it's 270 kilometer. Is it okay? If okay, give me your reaction. React to me. Then we continue with C. Okay, thank you, Megan. Okay, boys and girls, apart from the times when they stop, okay, we ignore the part they stop, and we're only talking those they are moving. So, which section of the journey was their speed slowest? Which section they having the lower speed? What do you guys think? And tell me your answer. Why you think that section actually is the slower section? Okay, so boys and girls, tell me your idea. Hui Tong, your answer is correct. Gradient is lower than other section, but section one and first section and last section gradient is different, no? You be careful and have a look again. First section and last section, are they having the same gradient? Actually, no. So which one having a lower gradient? Yes, correct, Hui Tong. Yes, Licious, finally you are here. I thought you are not here. Okay. Right, boys and girls, the last section at here is the slowest. You see, slowest. This one actually is faster a bit. As I told you, the gradient represent the what? Speed. Okay. So can you see that this line and this line? Gradient is different. Okay. So the last section at here actually gradient is smaller gradient. Or we say the slope actually smaller slope. Okay. It's already almost horizontal. Okay, like boys and girls, compared to other section, actually last section having a slower speed. Okay, so at here explanation, you can answering like lowest gradient, smallest gradients, or we say smaller slope. Okay. Okay, boys and girls, you goes to the D. Can you calculate the average speed for the whole journey? Your answer must be include the unit. 4 marks. If 4 marks, please write formula, substitution, final answer, and unit. 4 marks. My boys and girls, write down, do it, and then tell me. Calculate the gradient. Calculate the speed, average speed.
Okay, Hui Tong giving me the answer. Hui Tong, make it two significant figure. Make it two significant figure for your IG exam. If you go through to the past year paper, all the answer scheme they were trying to round to, most of them is two significant figure but sometimes it's three. Yes, correct, Hui Tong. How about others? Actually not difficult. What idea? Give me the answer. Average speed is total distance divided by total time. What is your total distance? What is your total time? Divided it. 4 mark, always look at the marks that allocated for you. Sometimes it's easy, but 4 marks is a lot. We have to do some formula, substitution, final answer with two significant figure and unit. Roshan correct, Xuan correct, Emily correct. Okay, dear. Total is 300. Total time is 6.5. So for this question, in order to score 4 mark, V equals to S over T, total distance divided by total time. Okay, so this one is 300 kilometer divided by, what is the time? 6.5 hour. So we'll get 46 kilometer per hour. 46 kilometer per hour. The unit actually is depend from your graph. It might be in meter per second. Okay, it might be meter per second, so depends on your question. So for our question at here is in kilometer hour, so kilometer per hour. Okay, now boys and girls, we go to the next. A bus travels at a constant speed. Okay, travel with constant speed. So first, constant speed. How was the graph for your constant speed? Okay, so constant speed, that means that it's moving. Am I right? It's moving. So if moving, that means that it will be a constant gradient. So your graph should be like this for constant speed. Okay, it stopped for a short time. It stopped for a short time. So this one, second motion is stop. Okay, if they stop, then stop at some way. So it will be like this, zero gradient. And then travel with a higher constant speed. Again, constant speed. So constant speed should be a line something like this. But right now, higher constant speed, that means that my gradient must be higher. So I should draw a steeper line. So actually got three part of motion. We have to combine these three. Constant speed. So at here, constant speed. Okay, something like this. Constant speed. Okay. Stop for a short time. So stop for a short time. Okay, then with a higher constant speed. So I should draw another line, but this line have to be steeper than just now the first one. Okay, something like this. Is that clear? Like boys and girls, give me some response. Is that clear for this question? Okay, Hui Tong, thank you. Okay, sure, Megan. Okay, like boys and girls, we go to the page number 7. Now we learn something new. Okay, what we're talking just now is about distance time graph. Right now we are going to speed time graph. Okay, so at here we goes to your next page here. Okay, speed time graph. First, can you help me to find out what is the gradient from this graph? Can you help me to find out what is the gradient and what is the unit from the gradient? Okay, can you try do calculation and then tell me what is the value for the gradient of speed time graph this? Okay, and what is the unit for the gradient? Y2 minus Y1 divided by X2 minus X1. This is your what? This is your mathematics. Okay, finding the gradient. Okay, Megan correct, but if you give me this answer, I won't give you any marks. It's because, guys, remember boys and girls, remember, No fraction in physics, final answer. Final answer, no fraction. Please make sure you don't give me a fraction. Okay. Like boys and girls here. Hui Tong correct. Yes, correct, Megan. Okay. Boys and girls, gradient. If I take this point as 8, 4. So here is 0, 0. So here is x1, y1, x2, y2. Okay, so at here, gradient is y2 minus y1 divided by x2 minus x1. Y2 is 4 minus 0 divided by 8 minus 0. So your answer is 1 over 2. But in physics, we not accept with 1 over 2 as our final answer. We have to make it decimal, so 0.5. Okay, what is the unit? Unit on y-axis, because 4 minus 0 actually is my y-axis, okay? ms negative 1, okay? This way that we write, actually, this is Malaysia syllabus. We're using ms negative 1. Or you goes to the A level, Cambridge A level, we will write in this way. But for right now, we're using the slash to represent meter per second, okay? So the x minus 0, so x2 minus x1 actually is x is second. Meter per second divided by second. That means that you divided second for 2 times. So meter per second square. Okay, boys and girls, if not mistaken, lesson number 3, we're talking about meter per second square. Actually, is the unit of acceleration. So boys and girls, just now when we are learning about distance time graph, gradient is measuring speed. But right now, speed time graph, gradient is measuring acceleration. Okay? Area under the graph, like boys and girls, this one, this is your graph. Area under the graph actually is this area. Can you help me to count what is the area of this? Okay, count area for this. It is a triangle. So in your mathematics, what is the area? Hui Tong, the magnitude is correct, but unit is wrong. Okay, unit is wrong. So you try how you derive the unit for the area. Xuan correct, but can you give me the unit for the area under the graph? What is the unit? Megan, magnitude is correct, but the unit is wrong. So far none of you give me the correct unit. We turn correct already. Okay, like boys and girls, you look at here. Because this line, okay, they form a triangle. So this area actually is a triangle area. So we're using 1 over 2. Okay. So 1 over 2, the base is 8. Okay. Then the height is 4. So at the end, everybody, you get 16. It's correct. But the problem is, what is the unit? What is the unit? Okay, boys and girls, you look at here. X is second. 4 is meter per second. Okay? Second times meter per second. So your second and second can be cancelled out. So you will left what you need, meter. So when we do calculation for the area under the graph, actually we are getting distance. Is that clear? If just now the distance time graph, we calculate gradient, we get something. But we don't calculate area under the graph for the distance time graph is because it doesn't bring any useful information. But right now, speed time graph, we not only can calculate gradient, but we also can get some information from the area. So at here, after that, you found that you are calculating the distance. Okay? So at here, we look at the first graph at here. Can you see that? Actually, this graph, horizontal, is almost the same as what we talk at the front here. You see here, horizontal. Just now we say horizontal is at rest. Is it the same for right now? My answer is, it look like the same, but it different, bring totally different meaning. Okay, so we look at this. This speed got value. For example, I simply give some value. I give it like 10 meter per second. This is the value for the speed, okay? It maintained at 10 meter per second. Does the object move? Object is moving, dear. Object is moving. And it moving at 10 meter per second. It moving with constant speed. It moving with constant speed. The speed is constant. Can you see that? Constant. I simply could give some value for you to have a look. Okay, because the speed is meter per second. So I just simply put a 10 at here to let you know. Actually, it's moving because we got speed. Is there any gradient? Just now I told you horizontal. If you're using y2 minus y1 divided by x2 minus x1, actually horizontal line, you will get a zero gradient. What is the gradient to represent in our speed time graph? Gradient represent acceleration. If your gradient is zero, your acceleration is zero. Okay? At here, we said that object moving with constant speed. The graph looks like the same horizontal line, like just now, but it totally brings a different meaning. Is that clear for this? Give me reaction. Okay. Here next, okay? Second diagram. So you see, at here is 0. Speed meter per second. After that, we start to increase. Maybe at here is 4 meter per second. Here is 8 meter per second. Maybe like that. Okay? So for this one, you will find that the speed, what's going on? Increases. The speed increases. It's not distance, this is speed. Okay? Speed increases uniformly. Gradient. Is there any gradient? Slanted line like this. Yes, there is a gradient. Just now, this question, you calculate the gradient and show me 0.5. So this line, it will be a constant gradient. Okay, the gradient is constant. Gradient represent what? Gradient represent our acceleration. So how we say about this? Object is moving with constant acceleration. Why I know constant? Constant gradient. And why I know it's acceleration? Because gradient represent acceleration. Is it okay for second graph? Okay, thank you, Hui Tong. How about others? Is it okay for this second graph? Okay, Emily leh? Xuan? Okay, Emily able to follow, Emily? Okay, dear, next, third one. Okay, let us continue for this part. Okay, we will find that the speed is decreasing. Okay, the speed is decreasing. If you do calculation for gradient, you will get a constant value also, but this constant value actually is negative. So you write the gradient is constant and the value that you get is negative value. Gradient represent your acceleration. Negative acceleration actually is what? Any of you know? Tell me. Negative acceleration actually is? Tell me, idea. Tell me. Any of you got idea? Emily, correct. Hui Tong, correct. Meaning that decelerate is slow down. Decelerate. Okay, deceleration. So at here, how the object moving? Object moving with constant deceleration. Is slow down. Deceleration meaning slow down. Okay. Until page number 7. Any question?
No question. Give me the response. This just is not reverse, it's not going backwards, it's slow down, meaning that slow down, negative acceleration. Okay, acceleration, if we get 4 meter per second square, that means speed up. If we get acceleration negative 4 meter per second, it's meaning slow down. It doesn't bring the meaning of the direction, okay? At the same time, I can give you guys idea like this. We know that velocity also got direction. If let's say velocity 10 meter per second, meaning that it moving to the right. One direction, okay? If moving in the opposite direction, then what should we do? We should put a negative for it. Okay, so for velocity, the positive and negative bring meanings. Yes. Velocity, positive or negative, it bring the meaning of direction. Yes. When it moving in opposite direction, put a negative. But for acceleration, the positive and negative doesn't mean the direction. It means that it's speed up or actually it slow down. So you guys have to differentiate between these two. Velocity, positive, negative, bring the meanings of direction. But acceleration, no. We cannot know what is the direction. But we know that the speed up or slow down. Okay, is it okay? Okay, then we go to page number 8. Is it okay? Okay. Next. Like boys and girls, if I combine some of the pattern, do you still able to identify? Okay, like boys and girls, you try to write down your answer. I give you some section. This is 1. This is 2, section 2. Section 3. Section 4. Like boys and girls, type your answer in the chat box. 1, 2, 3, 4. Describe the motion. What is your number 1? What is this motion? Number 2, what is the motion? Megan, 1 is correct. Continue. Xuan, correct. All correct, Xuan. Emily, you cannot write constant only. Constant what? Constant distance, constant speed, constant acceleration. What is that? You have to mentioning in a complete way. We talk also the same, cannot give me constant only. I don't know what is constant. Constant, yeah, let me have a look. Hui Tong, 4 section, 3 section correct. 1 section is wrong. Megan's correct. 1, 2. Emily, 4 section got 2 section correct. Got 2 section is wrong. Right, how about others? Okay, here, boys and girls, here. First section, look at the speed at here. Okay, Emily, you look at the speed at here. This one, first section. Speed start from 0. Speed is 0. Speed is 0 meaning that what is the motion? Speed is 0. That means that speed is 0. That means object right now is stationary. Or we say object at rest. So first section, object at rest. Okay. Second section, okay, 0. Maybe here is 10. Here is 20 meter per second. So can you see that it's increasing the speed? And this is a constant gradient. So I want you to add one word called constant acceleration. Sometimes they will allocate 2 marks for this. 1 mark is for constant, another 1 mark is for acceleration. So I want you to write in more complete way, constant acceleration, because this is constant gradient. So it should be constant acceleration. Acceleration is already correct, but more incorrect, I mean, it's like more in detail, it should be constant acceleration. Okay, next, dear. Emily, you look at this section. This section is horizontal. Is there any speed? Yes, there is some speed here. So we cannot say that it's stationary because we got speed. Okay? But this speed is maintained the same. So our answer for third section should be constant speed. Last section from 20 meter per second at the end goes to 0. That means that it slowed down. So it should be deceleration, but in more complete way, we say constant deceleration. Okay. Any question? Okay, thank you, Hui Tong. How about others? Can we proceed? If you catch the idea, then we can proceed to do some practice, do summary first. Megan, okay. Emily, is it okay? For this 4 section, is it okay? Okay, dear, here. Gradient of what graph? Can you help me to add more in detail? VT graph, okay? Speed time graph. Because we got 2 graph, although here I already writing speed time graph, but we have to be careful what graph we are using right now. Represent the acceleration. Gradient represent acceleration. Positive gradient, for example, acceleration is positive value. Negative gradient, meaning that this acceleration is negative value, 4 meter per second square. So what does it mean? Just now we got say accelerate, decelerate. Okay, one is bring the meaning of you speed up. So just now here, section 2 is positive gradient, so it speed up. Last section is negative gradient, so it slow down. Okay. Area under the graph represent what? Distance travel. Okay, is that clear? Okay, good job. Okay, dear, before we continue with the exercise, past year question. Any empty space? Let me have a look. I want to get some space. Okay, here. Okay, I need to capture using your eyes and store in your brain. Okay, we got 2 graph. One is called ST graph, distance time graph. Another one is called speed time graph. Okay, distance, speed, then speed, we goes to acceleration. Okay, this is what we learned in lesson number 3 lah. The starting from distance, then distance divided by time, we can get the speed. Speed divided by time, we can get acceleration. Okay, here, when our distance time graph, we finding the gradient, we will get the speed. Okay, when the speed time graph, we find the gradient, we will get the acceleration. Okay, then from the speed time graph, we go back and find area under graph. So I say AUG lah. Area under graph. I'm finding back the distance. This relationship capture using your eyes and then store in your brain. This is their relationship. Distance time graph find gradient, speed. Speed time graph find gradient is acceleration. Then speed time graph can find area under the graph. Go back, find distance. Is that clear? Okay, thank you, Megan. Like boys and girls, look at the question number 1. The graph shows how the speed of a van change with time for parts of its journey. In which level section is the van decelerating?
Try to answer. Which section object is decelerating? That means that slowing down. Megan correct. How about others? Hui Tong correct. Emily correct. Shun correct. Okay, correct. Answer is B. Okay, boys and girls, not only wants you to identify B is decelerating, the front part, first section at here, slanted line, okay, before A. This is constant A. Constant acceleration. Okay, section A. Section A is constant speed. Section B is decelerating, slow down. Section C, you see, at here, this one, the speed is 0. So this one is at rest. Then this one, section D, is constant acceleration. Okay. Is it okay? Okay, thank you, Hui Tong. Okay, so we goes to your page number 9. Right, boys and girls, we goes to page number 9. Okay, wait. Okay. What does the area under the speed time graph represent? Speed time graph, area under the graph for speed time graph. It can represent, the answer is easy. Just now I asked you to capture using your eyes and then store in your brain. Area under the graph, go back. We are finding the answer. Okay, thank you for answering me. Answer is donkey, distance. Okay, distance. So boys and girls, we goes to this question next. Speed time graph. Describe the motion between PQ. PQ, what is the speed? What is the motion? QR, what is the motion? Okay, right? Try and then tell me your answer. Shun correct. Hui Tong, no. One correct. PQ is correct. QR study. How about others? Megan correct. Emily, right? Emily. Hui Tong correct right now. Hui Tong, you know the problems? QR. Okay, good. Emily correct. Okay, right dear. Answer will be A, Answer will be A. This is acceleration, is because speed increasing. Okay, acceleration. Constant acceleration. Okay, QR at here. You see, this is the speed with certain value. Let's say we put 10 meter per second. So this part actually got motion. Got motion. Okay, it moving with constant speed. So answer is A. Okay, number 4, right guys? How far? That means distance. How far does the object travel at constant speed? Okay, can you guys try and then tell me number 4, how far? Xuan correct. Unit. Not capital letter, Right, the others? Try to do calculation and tell me how far the object travel at constant speed. You have to identify where is your constant speed, Where is your constant speed? Emily, constant speed is in this region, This part. From 5 to 15 is constant speed. So they want you to find this area. Hui Tong correct, but unit is wrong. Megan, calculate how far. Yes, Hui Tong right now, correct. How far? Okay, how far? So how far, that means that what they're asking, distance. They're asking you about distance. Okay. So at here, this is a rectangle. So we no need to using 1 over 2. A lot of students will ask me, teacher, just now at start, we're using 1 over 2 times the base times the height. What? That is because that is a triangle. That is this area, triangle. So we need to using half of it. In your mathematics, this is a rectangle. We no need to 1 over. Okay, so at here, distance, I want you to write and practice. Distance is equals to area under graph. Okay, boys and girls, this is considered one formula. This is considered one formula. So every time when they're asking you to find distance, please write this sentence. They assume this is a formula, okay? Then area under the graph here actually is 10. The time, how far they travel, 10 seconds. Then this one, the speed is 5 meter per second times with the 10 second. So can you see that? 50. What is the unit? Second and second we can divide it. So we can cancel out. So it's 50 meter. Meter is what? We are measuring distance. Unit for distance. Is that clear, dear? Is it okay? Okay. How about others? Emily, is it okay? Megan? Okay. Xuan, should be fine, right, Xuan? Okay, like dear, we go to the next page, page 10. Speed time graph show is for a bus traveling between stops. Oh, it's travel, after that they stop. Where on the graph is the acceleration of the graph of the bus greatest? This is a bit tricky, so can you try? Oh, Xuan already got answer. Xuan correct eh? Not bad. But how about others you think? Where on the graph is the acceleration of the bus greatest? Which section is the greatest acceleration? Megan correct. Hui Tong and Emily, what do you think? Licious, are you with us? Hui Tong, no? Emily, correct. Oh, okay, you are here. Okay, dear. Acceleration, acceleration. From the speed time graph, how we find gradient? So as I told you, we can draw the line to show the gradient. Which one have a highest gradient? Answer is B. Steeper line. Or we say, okay, so A, B, C, D. If we draw the line, gradient line, we will find that B is steeper. Okay, so at this moment, actually, B is the greatest acceleration. Is it okay? Give me a response so that we can proceed. Okay, thank you, Hui Tong. Okay, like boys and girls, we go to the next. The cyclist has the greatest acceleration between what second to what second? What second and what second we have the greatest acceleration? Shuan correct. Oh, the B also correct. How about others? Hui Tong correct. Hui Tong, you can proceed with the distance travel. How about Megan, Emily? Megan, no. Megan, no. which line is steeper line? Greatest acceleration, so you refer to the steeper line, higher gradient. Like Emily, eh? Yes. Okay, boys and girls. So you look at this line and this line. Which one steeper? Answer is first section is steeper. So for the first section, is the greater acceleration is 0 to 5 seconds. Okay, 0 to 5 seconds. Then after that, the question asks you to calculate distance travel between 10 to 25. 10 to 25, this is 10 to 25. They want this area. What is the area they travel? Okay, remember, write down the formula. I told you distance formula, we have to write like this. Area under graph. Okay, do calculation for this part. Hui Tong correct. From here, time to time, here is 15 seconds. Height is 8 meter per second, so it's 8 meter per second times with the 15. So your answer should be 120 meter. No, why is meter? Meter per second times second. So second cancel is meter final. So it's 120 meter. Okay. So 1, 2. This is two significant figure. Okay. Any question? React to me. There we go to page 11. Okay, thank you. We go to next page. Okay, dear, here. State the maximum speed. Look at the graph. What is the maximum speed? Xuan correct. How about others? Hui Tong correct. Emily, Megan? Maximum speed. What is this graph? Speed time graph. What is your maximum speed? Emily, Megan, Let me have a look, Megan. Megan correct. Emily, you type one more zero. It should be 100, right? 100 kilometer per hour. Okay, 100 kilometer per hour. Okay, then at here, identify the region of the graph showing that the train moving with constant speed. Which region is moving with constant speed? Shuan, correct. Shuan could continue. C and D. Correct, Hui Tong, Megan, Emily. Megan, correct, Emily. Which area is constant speed? Correct, Emily, but there is another one more answer. Not only the one answer is two answer. Shuan correct. Good job. Correct. Okay, like boys and girls, this area is constant speed. LM and RS. LM and RS, they got speed 100 kilometer per hour and 60 kilometer per hour. That means they're moving with constant speed. Yes. So at here, LM and RS. Okay, but I'm not only at here. I want you guys continue. KL. Starting at here, KL, you write down constant acceleration. Okay, I want you guys write it down for me. What is MN? And type in your answer. Type in your chat box. What is your PR? What is your PR? PR. What is your PR? What is your ST? And here I want also one more called NP. Can you help me to label what is the motion? LM and RS I already know is constant speed. How about others? So can you guys try to identify and then type it out? Let me know. Shuen, no. For the D, no. Hui Tong, MN, correct. How about others? PR, correct. Hui Tong. Megan, correct. MN. Hui Tong, ST, correct. Then one more MP. Megan, PR, correct. ST, correct. How about the last one, MP? Ah, good job. Emily, are you okay? Correct. Megan, correct. Xuan, correct. For the D, correct. Okay, so boys and girls, oh, okay. Typing error. Okay, MN at here, MN. Can you see that the speed decreases? So it's constant deceleration. PR going up, speed increases. So constant acceleration. ST going down. So it's constant deceleration. I add one more MP because you guys will make mistake for this part. This part and here, they are horizontal, but actually it's different thing. This one horizontal with speed. Horizontal with speed, so it's constant speed. But this one horizontal without speed, so this is at rest, object at rest, okay? So this one you write at rest. Okay, now boys and girls, you try with C. State the time in minute for which the train was not moving. Correct, Hui Tong? C correct, like others? How long the time is not moving in minutes? Hui Tong, D correct. Now we wait for others. Emily, do you able to follow us? Okay. Emily, try with the C and D. How long the time the train was not moving? Actually, in minutes. Megan, Megan. C and D. Megan, correct. Okay, not moving, not moving is this area, not moving. So it's actually 0.1 hour. Don't forget this unit is in hour. They ask you to convert to minutes. So 0.1 hour convert to minutes. So it should be 0.1 times 60. So it's 6 minutes. So this is 6 minutes. Okay, what is the distance traveled by the train between the point M and N? Point this. Okay, what is your area? What is your distance from here? Okay, so Megan, no. How about others? What is the distance traveled between M and N? We don't already get the answer. Emily, this area under the graph, can you count? This is a triangle, triangle. No. How you get it? Okay, let me have a look. Megan, correct right now. Okay, this is the distance. Distance is actually area under the graph. So for this question, you see this is a triangle. So it's 1 over 2. The base at here is 0 0.2 hour. 0 0.2 hour times the height. Maximum height is 100. So this triangle is something like this. Triangle. So here is 0 0.2. Here is 100. Okay? Height is 100 kilometer per hour. So can you see that hour and hour can be cancelled out? Okay, so at here, 0 0.1 times 100, so it should be 10 kilometer. Is it okay? 10 kilometer. You don't purposely convert the hours to minute right now, because the 100 is in kilometer per hour. We standardize the unit for the time. Okay? Just now only asking about the time in minutes, so we only need to convert. But at here, when we calculate the distance, because kilometer per hour, then your x-axis also in hour, so we no need to change. Okay, is that clear for this question? Nine boys and girls, respond to me. Okay, we talk okay. How about others? Megan? Okay, Emily okay? Emily okay? Okay, Lydia, we go to the next question, Lydia. This one is ask you to sketch the graph by yourself. Okay, like boys and girls. The students describe the part of the journey. The bus accelerate from rest at a constant rate. That means what? Constant acceleration. Okay, in speed time graph, constant acceleration. This is speed, this is time. Okay, it can be in meter per second or kilometer per hour for the speed. Okay, so at here, constant acceleration from rest. That means starting, initial velocity is 0. So we start from 0 here. Okay, accelerate, that means speed up. So our graph should be something like this. Okay, for 10 seconds. So this one 10 seconds. It reached the maximum speed at 10. Oh, okay, they tell us maximum speed is 10. Okay, 10. So here, maximum speed 10. The bus maintain constant speed of 10 meter per second for 60 seconds. So how? Okay, let me erase a bit forward. Okay, wait. Okay, it's here. It's the first section. Okay, first section is here. Second section, it maintain the constant speed. I highlight, accelerate constant. So now it's maintain a constant speed. Constant speed maintained for 10 meter per second for 60 seconds. For 60 seconds, that means that just now is 10. Now we are going to continue to another 60. So it should be goes to 70 lah. Agree? So it maintains. So it goes for another 60 seconds. So red color here is actually 60 seconds. So from 10 seconds to 70 seconds is 60 seconds. Okay. Then the bus decelerate. Okay, highlight. This is the third motion. This is the second motion. Okay, I'm using red color. Third motion, I'm using green color. Decelerate, that means slow down. At constant rate, that means constant deceleration for 15 seconds. 15 seconds, just now I already used 70 seconds. Another 15 seconds, I will be goes to 85. Right? Okay, I will decelerate until it stops. Stop, that means that final velocity is 0. So from here, I will slow down until I go to the 0 and I stop. This is how the graph showing you. Is it okay? This is how the graph showing you. So boys and girls, can you try to sketch it into the graph here? Okay, remember in your exam, please all drawing have to using pencil. Okay, drawing using pencil. Whatever, if you make mistake, at least we can erase it and then we can give another answer, correct answer. But if you using pen, if that is a wrong answer, then you spoil everything. Okay, like boys and girls, try to sketch on this. 0 until what? 10, somewhere here. Then in band 10, another 60 seconds, which is I need to go to 70 here. Okay, then I goes to 85 and I stop it. Okay, this is my answer. Yeah, Hui Tong, you go toilet. We give Hui Tong 1 minute. Okay, so digest for this question. Any of you want to ask me question, idea? You may ask me right now. Okay, 3 section thing. So you add on the time. 10 seconds, another 60 seconds, so it goes to 70. Another 15 seconds, so it goes to 85. At the end, we stop at 85. Okay? Any of you, any question? If no question, give me a response. Okay, any? Shuan? Correct, Shuan, correct. No question, thank you. Like dear, comes to this, on another part of journey, average speed is this. Distance, they ask you to calculate distance travel in 150 seconds. Oh, that means that it's not related with the, it's no related with this graph, it's another part. So can you do calculation how far it travel in 150 seconds? The speed is 7.5 meter per second. Okay, how far the bus will travel? Distance, how far the bus travel? Any of you got answer? Let me know, dear. Okay, correct, Hui Tong. Speed is distance divided by time. Speed is 7.5. Distance, I don't know. Time is 150. So when we apply, it should be 1125 meter. Okay, if we make it three significant figure, 1130 meter. Any question? No question, we goes to your page number 13. Give me a response, then we can proceed. Okay, Megan say okay. Like dear, set the speed at start of 30 seconds. At 30 seconds, what is your speed? So basically it's easy. Here 30, wait, at the start of the 30 second. At the start, oh, total is 30 second. At start, what is the speed? So at here, at start, what is the speed? At start of this 30 second, at start here. Okay, when time equals to 0 is starting. So here, what is this speed? So this is half of 10 and 20, it should be 15, 1, 5. Okay, start, that means that starting time equals to 0, 1, 5. Okay, yes. So what is the end of the 30 second end? So what is your end? After 30 second, what is your speed? Speed time graph, you just refer to this reading. So at here, the answer should be 0. Okay, this is start. This is end. Okay, can you describe what is happening to the speed during the period 0 to 10 seconds? And this one just now we practice a lot. Okay, we practice a lot. Speed increasing and then constant gradient. So we say constant acceleration. Oh, okay. But they're asking about speed. So I need to talk about the speed. So here highlight speed. Now they emphasize about speed. So we say increasing, speed increasing. 10 to 25, we say constant speed. 25 to 30 is decreasing speed. I'm not using the word of acceleration is because right now they're asking about speed. Okay, if they say what happened to the motion, then we can write constant acceleration or increasing speed or speeding up. Okay. Okay, can you calculate the distance traveled in the last 5 minutes? Last 5 minutes is here. Okay, like boys and girls, count and then tell me your answer. Last 5 minutes. What is your answer for the last 5 minutes? How far they travel? Xuan, so B, we talk about the speed. So I don't want the answer about acceleration. Of course, answer scheme they accept. But here, because I'm more strict lah, okay? Speed, speed. So we're talking about what happened to the speed. Speed increasing, speed decreasing, constant speed. Okay, answer C. Friends already give me the answer, correct? 75. So distance actually is area under the graph, okay? So 1/2, the height is 30, the base is 5 seconds, so your answer should be 75 meter. 3 mark, dear, 3 mark. So it might be this as formula 1 mark, substitution 1 mark, final answer 1 mark. So do not skip any working set, okay? Total distance in the 30 second is 750 meter. Can you calculate the average speed? Easy. They just want to test your idea. Do you know how to calculate average speed? So average speed is distance divided by time. Total distance 750 divided by time 30. So your answer is 25 meter per second. 3 mark again. See 3 mark. Formula 1 mark. Substitution 1 mark. Final answer 1 mark. Is that clear? Okay, Hui-Tong say yes. Then we goes to page number 10. Xuan also say yes. So we goes to page number 10. Okay, page number 14. Sorry, page 10. What? Question 10. Okay, this is a very good question. And it trying to trick you. Why I say so? We look at here. This is a speed time graph. On the journey, he work and then wait for the bus. So he work and then wait for the bus. Okay. Then he travel by the bus moving. He get off the bus and wait for 2 minutes. Then he work again. Total journey is 74. Okay. Total journey is 74 minutes. Okay, like boys and girls. For the whole journey, can you calculate the distance? What is the distance? What is this graph? Speed time graph. Distance, how you calculate distance? Area under the graph. So you should do calculation for this part, plus this part, plus this part. This is the area. It work by bus and work again. But here, why I say they're trying to trick you? Look at the axis. Look at the unit on the axis. So at here, I highlight for you. Kilometer per hour. How about time? Minute. Be careful with the unit. They're trying to trick you. They give you the different unit. So what should we do? We should make it standardized. Okay? So at here, I want to find the kilometer. How far they travel kilometer in kilometer. Here, kilometer. What should I do? Area under the graph. For the first section at here, this is, I think, 5, okay? 5 kilometer per hour, am I right? Times, you have to be in hour. In hour, hour and hour, we can cancel out. So we'll get the distance. But here 20 minutes, how can I convert to hour? Okay, 1 hour is 60 minutes, right? 20 minutes, how many hours? In your mathematics, do you remember cross multiply? So actually, how many hours you should using? 20 divided by 60. If you're using 60 divided by 20, you want to tell me 3 hours. 20 minutes is 3 hours? No, it's not 3 hours, okay? It's 20 divided by 60. Okay, so this is the first section. Second section, third section, you do the same way, convert the unit. Can you tell me how far the distance travel? Now you type your final answer to me. Now you guys, do you able to get the answer? Tell me, tell me. Yeah, Hui-Tong correct. How about others? Only Hui-Tong get the answer. How about others? Okay. What is your answer? This question actually, they want to trick you by giving you the different unit. So we have to be careful and then we convert it. Megan, no. Megan, no. Megan, no. You check your working step. Is it same as mine? Is it 74 minus 52? Or maybe you make mistake at somewhere here. Okay, our final answer, it should be 17. Please double check. Did you able to get 17 kilometer? Xuan, do you able to get this answer? Yes, okay. Average speed, total distance divided by total time. So total distance 17 kilometer divided by total time. Total time we use is 74 minutes. Convert it into hour because kilometer pairing with hour, we are very seldom say kilometer per second, no. Per minute, no. Kilometer per hour. So 74 goes to the hour, it will be 74 divided by 60. So 74 divided by 60 hour. Your answer for this question, if you do it correctly, the idea, 14 kilometer per hour. Is that clear? Hi, dear, give me some response. Is that clear for this question? Okay, thank you, Emily. Okay, thank you, Megan. Like dear, last two. State and explain which features of a speed time graph show you acceleration. I want to know about acceleration from this graph, how I know. How I know the acceleration is constant acceleration, zero acceleration. How I know. Acceleration, just now I asked you to remember, capture using your eyes, store in the brain. How I know acceleration? I finding gradient. Am I right? Gradient. gradient of your ST graph actually is equals to your acceleration. So gradient y, set the reason. Gradient is equals to the change of speed divided by time. So this is actually acceleration. Last question. Somebody try to answer me. State and explain the acceleration of the person at time 40 minutes. At time 40 minutes is somewhere here. 40 minutes at here. What is the acceleration? Like boys and girls, any of you can help me to answer this. At 40 minutes, what is the acceleration? And explain to me why you say acceleration is this. Megan, correct. But why? Your answer is correct. Why? State and explain. Explain how why you say acceleration is equals to this. What is the acceleration? Any, dear, any? You see, speed time graph, we find acceleration, we're using gradient. What is this gradient at here? What is the gradient at there? Yes, correct. Okay. Hui Tong, no. So, Hui Tong, you see, here, Megan idea is correct. Okay, this is horizontal line. If you're using to find the gradient using 2 point, y2 minus y1 divided by x2 minus x1. Your gradient at here, actually, your gradient is 0. 0 gradient. In moving with constant speed is 0 gradient. Acceleration also 0. Here, acceleration is 0. Gradient is 0 because gradient is 0. Okay, let me go back to here. This one. This one. Okay. Horizontal line. Constant speed. What is the gradient? 0 because this is horizontal line. Acceleration, what's going on? 0. Okay, so it's actually asking this part. So at here, the last one, we fill in the blank. State and explain the acceleration of the person at time 40 minutes. Okay, acceleration equals to 0. Why? Gradient equals to 0. Object move with constant speed. 2 mark. State and explain. Actually, it's 2 questions. State and explain. State what happened to acceleration and then explain the answer. Okay, so we complete chapter 2. We already complete chapter 1 and chapter 2. Next week, we're entering chapter 3. Until right now, before we end our lesson, any of you got any question? If no question, can you give me response? Then we understand that we can stop at here. Okay, Xuan, we talk okay, Megan, Emily, Licious?